Welcome to the GallifreyNerds.
It's Saturday.
I guess it's Saturday.
Welcome to Rock Climbing 101. Who are your instructors? I'm Alex.
I'm Kylie.
We're gonna walk climb. Step one about rock climbing is called hip movement. Get up there, you're looking for a spot, do some hip movement. Keep the momentum going with your hips.
Alex, what do you do if you come to a spot where you don't think you can do it?
What you do is you look for one rock in particular, and you dyno. You pretty much just jump over it. Dyno.
Alright, I'm going to show you the incorrect way to do it since Alex is such a master. What you do is find yourself a solid foundation. You map out where you're going to go, and you try and see a visual path. And how I'm going to do this is I'm just going to be using my legs to actually support myself and bring myself up, and my arms to give me a little more momentum. What you're supposed to do. When you can't hold on any longer, you go safely onto the pad that you place below you.
You see, that whole planning, your pathing, it really just gets in your way because you're thinking about things, and you've got it all planned out, it's just clutter for your mind. You just need to feel the rocks, feel where he wants you to go. Shit, where do I go? Alright, Internet, today my letter is Q, and for Q, I'm going to do a little thing called Quantum Teleportation. Now let me describe to you what this is. This is teleportation on the quantum level. Now why do we have to go through all this quantum stuff in order to do teleportation? Can't we just analyze a whole system of things and then transport them from point A to point B? Well, no. It's this nifty little thing where we do teleportation on the basic quantum level. What you're going to do is you're going to have point A and point B. And you've got two little fiber optic lines running to and fro, and there's there's an analog line running in between them. So it kind of makes this little right triangle looking thing. You've got point A, point B, and you've got particle A and particle B. We'll call them Alice and Bob. Now what you do with Alice and Bob here is if you want particle B, if you want to transport A to B, then what you're going to do is you're going to take a third particle, we're going to call it particle C. It's going to entangle with particle A. Now when something becomes entangled with it, it means these two particles exhibit the same qualities at the exact same time, even if they're over a separate amount of distances. So if like particle A is going this way, and it's entangled with particle C, they're both going to be going that way. And it's not going to be a delayed effect. They're going to be going simultaneously, because then that information would have to be traveling over to the other particle faster than the speed of light. All right. So basically, what you do here is you take particle C, and we're going to entangle it with particle A, wrap it up, make it all nice and cozy like, and it's going to get sent down through that fiber cable, and it's going to arrive at point B. Now since it's entangled with point A, it is exhibiting the exact same qualities as particle A, simultaneously. So if you were then entangle C with B, since if you're entangling with C with B, then B is like C and C is like A, therefore B is A. And then all you have to do is you have to use that little analog line to let particle B know what state of matter particle A is in. And then you have, for all intents and purposes, transported particle A to particle B. Alright, you limp dick swirl turtles, here's my question for you. And if you don't answer it, I'm going to make you marry my oldest daughter. She is not pretty. That's the reason she's not wed yet. That unfortunate girl. Anywho, my question is, if you had to live either in the air, in the sea, or in the trees, which would it be? She ain't pretty. Gallifrey nerds, I'll see you tomorrow.